Hey guys, this is Mitch with FinePoint CGI, and today we're going to talk about how to build a grid-based path building system inside of Godot. So we're going to go through the process of raycasting to detect the objects around us. We're going to change out our object based off of the type of objects that are around us. We are also going to talk about how to create a grid-based object moving system. We're going to instance that object into our scene and be able to move it around and delete it and link them up next to each other so that they're kind of reactive next to each other. And we're going to talk a little bit about how to handle object references before they get deleted, because a lot of times I see a lot of people coming back to me saying, hey, my Godot game crashed because, I was deleting it while there were some threads out there. And I feel like that's something that's not very well explained to people about how the physics system kind of handles things. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing that we need to do is we need to create our path object. So what I'm going to do is I'm going to go ahead and create a 3D scene. And I'm going to go ahead and we're going to go ahead and right click our spatial node. We are going to change its type to a static body because it's going to be a static body. It's not going to be moving too much. And then we're going to go ahead and right click it, add in a child node. We need to add collision to this object. So let's add a collision shape here. And we'll go ahead and make it into a box shape. I'm going to make this kind of small. Now, all of these little blocks in here are going to be centered in the center, and you can, they're going to be 2 by 2. So that's why we're going to make our collision that way. Now, we're also going to right click our spatial node. We're going to add in another child, and we're going to add in a spatial node, and we're going to call that spawn under. Now, this is going to be used to spawn our object once we instance it into the scene. Now, you'll see I already have a bunch of scenes and things like that in my scene. So if you guys need, you guys can go ahead and check out the link in the description below to pull down this base project. Now, I'm going to go ahead and just kind of show you what these guys are. So we'll double click on that. You'll see we have a path. You'll see we have another path here, just like that. If I double click on my T, you'll see we have a T object. And if I do my path turn, you'll see we have a turn object. So those are the, four, I think. Yeah, 4 different ways that our path system can, items that our path can instance. So basically it's going to instance in one of these guys to represent the different path types that we have. So now that we have this, let's go ahead and save this scene, Control S, and let's name it path spawner.tscn. Okay. And what we're going to do is we're going to click on our top spatial node here. We're going to rename it. We will name it path spawner. And we're going to go ahead and save that. Right click. We're going to come up here, change it to C# and name it pathspawner.cs, and we will go ahead and create that. Now it's going to go ahead and open up VS Code. Let's go ahead and start building this thing. So the first thing that we need to do is we need to get a reference to our spawn under object, because we're going to be spawning under this little spawn under object, and we want to make sure that we have a reference to that, so that way we don't have to go and hunt it down all the time. So what we'll do is we'll say public spatial spawn under, just in case we need reference outside of it. Technically, we can make this private if we wanted to. And then we'll say spawn under is equal to get node as a spatial, and we will grab our spawn under object just like that. And now that we have that, we need to get some references to our path objects. So let's go ahead and come up to our top and let's get a reference to those path objects. So what I'm going to do is I'm going to do an export here, just like this. And I'm going to go ahead and say public act scene. And I'm going to go ahead and make a path scene for each one of my objects. So what I'm going to say is path object. And then I'm just going to go ahead and grab these guys and I'm going to duplicate it 4 times. So we'll go ahead and duplicate it 4 times. We'll say path T object. We'll say path turn object. And then we'll say path 4 way object. And that'll allow us to have a reference to those objects so that way we can spawn them individually. And it's also going to be exported so that way when we go back to our path spawner, we can actually go and drag these guys in instead of needing to hook it up through code. We can just hook it up through our editor. So now what we'll do is we'll go ahead and set up our set path, right? Because we need to be able to set what path we have. So if we come in here, we'll go ahead and say public void set path. And what we'll do is we'll go ahead and basically check the objects around this object, and then based on that, spawn our path, okay? And it'll be pretty simple, but it's going to be a lot of code because it's a lot of really random use cases that we have to actually plan out. So what we'll do is first, we need to go ahead and remove any objects that are under our spawn under, because if we have an object under our spawn under, then we're just going to be duplicating objects. So what we'll do is we'll say for each spatial item in spawn under dot get children, just like that. And then what we'll do is we'll say item dot queue free, and that's just going to go ahead and delete any items that are underneath this object. And then what we'll do is we'll raycast for all the objects around our spawning object, okay? And what we're going to do is we're going to do a little bit of fancy coding here. Instead of using a raycast object inside of Godot, I'm just going to do it through code. It's a little bit more efficient, I guess. I don't really know if it's efficient, but it's just easier for me to understand. And a lot of times raycasting through code updates differently than raycasting through the editor raycast, or at least that's what I've noticed, is if I use direct screen space and I cast it myself, it tends to give me different results or more consistent results than if I do it through the node system. So what I'm going to do is I'm going to go ahead and say space state is equal to get world dot direct space state, okay? And what this does is direct space state is direct access to your world's space, right? And basically what I'm doing is I'm fetching that world space state so I can actually fire off my raycast, okay? And then what I'm going to do is I'm going to say dictionary, which is a Godot dictionary, not a C# dictionary, result is equal to space state dot intersect ray, which is my raycast, and then you have to give it a vector 3 from, a vector 3 to, and any arrays to exclude or anything like that, right? So what we'll do is we will say from our current location, so translation, comma, to translation, and we need to give it where we're going to raycast to. So we're going to say from our center point to our center point plus what direction, right? So if we look at our object, we're going to be firing off from our z-axis. So from this direction, this direction, this direction, and this direction, right? So from our minus x, our z, and our minus z, okay? So what that means is that we have to say our center point plus this direction, okay? So you can see that that's about 2 units, maybe. Maybe we might want to make it 3, but we'll say 2 for now. And the same thing on the opposite side, we'll have to say, minus z 2 units. So that's basically how we're going to approach it. So if we go back into VS Code here, we can go ahead and say translation plus new vector 3. And in our case, it goes x, x, y, z. So we'll say 2, 0, 0, and that'll fire off our raycast in our positive x axes. And actually, it looks like our collection needs to be a Godot. Let me see. This is a Godot dictionary. This is a Godot collections dictionary, which apparently is a different thing. So what we'll do is we'll say Godot.collections.dictionary, just like that. And that'll basically clear that up. So that way the system knows what kind of dictionary we're trying to do here. We'll do that. There we go. And then We'll go ahead and put a semicolon. And then we need to go ahead and tell us what objects we want to exclude. And we want to exclude ourselves, right? We don't want to actually have ourselves as a collidable object, or else we'll never get anything back. So we'll say, and this needs to be a Godot collections array. So what we'll do is we'll say new Godot dot collections dot array, and we will go ahead and do an open curly brace and just pass in this. And that's just going to pass in this so that way we make sure that we do not affect ourselves. So now from here, what we can do is we can go ahead and just print our results. So we'll say gd.print our results, just like that. And then what we'll do is we're going to go ahead and check if our object actually is a path spawning object, okay? And before we move any further, let's make sure that this actually works, right? So we'll come up here to set path. We'll go into our ready and just add set path. So it runs on startup, so that way we can actually test this. And I think that will do it for right now. So let me see. This is only raycasting on the x-axis. So we need to make sure that we put whatever object we put in here, we make sure it's on our x-axis. So I'm going to go ahead and create a new scene. It's going to be a 3D scene. And I'm going to drag in a path spawner just like this. And we need to make sure that when we duplicate it onto our x-axis like so. And then let's go ahead and run this and see, and we will say test scene, and we'll see if it just, works. So let's hit play and see if we get anything back with our raycast. Nice. So you can see we got back something. So that's good. You can see it's a collider ID, a normal, and a position. So that's perfect. That's exactly what we wanted. So now what we'll do is we will come in here. We'll come over here and we're going to first check if the collided object has a collider, because there's a possibility it might not, right? So we'll say if our result dot contains collider, then let's go ahead and see if it is the proper object. If result collider is path spawner, then we'll go ahead and print the object. Okay, so we'll just put this in here. So that way it only prints the object if it exists. Okay, now let's take a look at it. So if we refresh it, and it does its raycast, you'll see it comes back with the stuff like we expect. So yes, it is a path spawner and it is colliding. So that's perfect. So now we need to go ahead and determine if our 4 cardinal directions have objects around it. And if they do, we need to set them to that object. Now, this is going to be a pain because we're going to have to do this each individual time, and we don't want to do that, right? We don't want to do this every time. So we should probably make this into a function, right? So we'll go ahead and take that and we'll say public bool raycast for object. And we'll go ahead and pass in a vector 3, and we'll put in a raycast position. And then we'll just go ahead and paste that. And we're going to need to make a small adjustment here where we're going to return a Boolean of whether or not there's an object in that location, right? But we also need a raycast position, right? Because over here, we're doing a new vector 3. So we need to change this to just our raycast position. And that's going to make this into a function that's reusable, right? So we can actually reuse it here to determine if our 4 cardinal directions are good to go. And you'll also see that we don't have a path returning some kind of value. So what we'll do is we'll say return true. And down here, if none of this is true, we will return false. That way, we make sure that we return whether or not there's an object in that location. And now what we can do is we can say bool path connected x is equal to raycast for object, and we'll need to pass in a vector 3. So we'll go ahead and pass in a new vector 3, and we will say, since this is for x, we'll go ahead and say 2, 0, 0, and that will do it for that. Now I'm going to go ahead and just copy and paste this for our 4 cardinal directions. So path connected z, path connected minus x, and minus z. So now it just does all 4 cardinal directions. So path connected z means that this needs to be 0, this needs to be 2, this needs to be minus 2 because it is minus x, and this needs to be minus 2 over here on the z. So we have we look at this, we have our x right here, x on this side, our minus x on this side, our z, and our minus z. So that's what this is doing. So now if we come up here and we print our booleans, then we can go ahead and just let's grab this guy, let's duplicate him, drag him over here. And if you hit control, you can snap, and that will make it a little bit easier. And if we duplicate this guy and then duplicate this guy, you will see a bunch of trues and false and things like that. And that will work. So we'll go ahead and hit play. We'll select our current as our default scene. You will see that we get a bunch of trues and false and a bunch of static objects, and nothing is, of course, showing up. So if we come up here, we look at it, you'll see that we get true, 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 because this object has all 4 objects. So our raycasts are working. We have true, false, false, false. So that one means that this one must have raycast right here. You'll see that we have false, 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 true. That's this one firing down. False, 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 true, false. That's this one firing across. And false, true, false, false is this one firing up. So it's working the way that we expected. And you'll also notice that our raycasts go in order of where they are. So this one fired first because it's the top of the stack. This one fired next because it is the second one in stack. This one fired after that one, then this one, and then this one. So that's something to keep in mind. Now, next, what we have to do is we need to take those booleans and determine which object we're going to spawn. So what we'll do is we'll kind of walk through this pretty slowly because it's going to be a lot of Boolean statements and things like that. So what we'll do is we're going to check if each one of these is true, and if they are, we'll spawn the corresponding object. So we'll come over here and we'll say if path connected minus x and path connected minus z and path connected x and path connected z, then I know that I need to spawn my 4-way object. So we'll say spatial path is equal to path 4-way object dot instance as a spatial. And then we'll also need to make our spawn under have that as a child. So spawn under dot add child path. Simple enough, really. So now once we save that and we go ahead and run this, you should see the center one being a 4-way object, providing it didn't crash. So that's always good. Null reference exception object not reference to an instance of an object. My guess is if I go to my path spawner, I didn't set these guys. So let's go ahead and set that. So we'll go ahead and drag our path turn into our path turn, our path T into our path T, our path 4-way into our path 4-way, and our path into our path object. And that should allow us to run this. So let's hit Control S. Let's run this. Let's see if we get our 4-way object. And you'll see we got nothing. So if we go back to our test scene, my guess is because we don't have a camera here. So we'll go ahead and right click, add in a child node, add in a camera. Let's drag this back to about here-ish. We drag this down so we can actually see what we're looking at. That should work. Unfortunately, we really can't see it, so I guess it doesn't matter. So we'll go ahead and hit Control S and hit play, and let's see if that works for us. There we go. So you can see we have our first 4-way object. So now we need to go ahead and start setting up all of the rest of our objects. So what we'll do is we'll go ahead and spawn in our T object, because next should be our T object, right? So we should go from greatest to least, right? So if all 4 are connected, it's a spatial. If 3 of them are connected, it must be a T object, right? So what we'll do is we'll say if path connected minus x and path connected minus z and path connected x, then we need to spawn in our t object. So we could basically just duplicate this code, so copy it, paste it, and then say path t object. Perfect. So now if we go ahead and take a look at this and we come in here, we look at our center object and we see which way is our minus x minus z x. So if we look at it, minus x z, and then we have path connected x. So if we take our path spawner 3 and we delete it, and then we run this, it should come up with a t connected object. Or not. So I probably got that wrong. Let me see. True, false, true, true. So let's take a look at this. True, false. So path connected minus z is not correct. And that's because that's what we're looking for. So that was my fault. I thought it was path connected z. So we'll just kind of drag this guy up like so. So we'll drag him up here and then refresh this, and we should get a t object. Perfect. That's what we want. We got a t object. So now what we need to do is we need to determine all the 4 cardinal directions that we have. So if we were to spawn in this path t object here, if we go into the scene, you'll see that it is by default minus x, x, and z. So what that means is that we're going to need to rotate this object to determine our different locations. So you can see here, like this one, for instance, to do minus x, z, or minus z, z, and x, we would need to rotate the object by, it looks like minus 90 degrees, or I guess 90 degrees. It looks like it starts out at 180. So that's just something, actually, I think if we go to path t, and then we rotate this, it's minus 90 degrees. I was correct the first time. So it's minus 90 degrees. And then for us to do the opposite direction, it would be 90 degrees. And for us to do this direction, it'd be 180. So now that we kind of have an idea of what ones we want to do, what we'll do, we're going to change this to else if, because we don't need to check each time, right? And we'll say else if path connected minus x and path connected minus z, and instead of our path connected x, we'll say path connected z. So now if we duplicate this little bit of code here, and we'll probably start duplicating this if statement, to be honest with you, because there's no reason to not, we'll spawn our path object and we'll rotate it 90 degrees. So we'll say path dot rotation degrees is equal to a new vector 3, 0, 90, 0. And that's going to rotate it into the proper direction. So now we can basically just duplicate this 2 more times because we have our 4 cardinal directions. And then we can just change our if statement and our rotation. So what we'll do is we'll say path connected x, and we'll grab this, bring it down here, path connected x, and then we also will say path connected minus z. There. And I think that will do it. Let's take a look at it. And then we'll say minus 180, and then we'll say minus 90, because that's basically the 4 cardinal directions for us. So now if we hit Control S, we come over here, we go to our path spawner, or test scene, and we move this guy here, and we run it. You should see that it's going to face the correct direction. Yep, it faces the correct direction. You can see that the line, the long line at the back is on the back. If we move this object here to here, and we run the scene, you will see that the long line is on the back, which makes sense from the camera perspective. Long line should be over here on the left. It is, so that's correct. And then if we grab this object and we move it over here and we hit play, it should make it on the opposite side as well. Perfect. See, we got the long line right here. So that's exactly what we wanted. So now we need to go ahead and do our turn objects, right? Because our turn object is our next big one. It's if two objects that are next to each other, so for instance, minus x and minus z, right? Then we're going to spawn our turn object. So we'll say else if, and we want else if because if we were to not use else if this is true, so is technically this, and this, and this, and this. So we want to make sure that if this is true, it breaks, it moves on. So that way we don't get inconsistent results. So we'll say else if, and we are going to start with our path connect, I don't know, minus x and minus z. Seems reasonable enough. We will start with path connect x and path connect minus z. So path connect x, comma, path connect minus z. And we'll go ahead and basically just duplicate this first half of the code. So Control V, and we'll say path turn object.instance. And let's see if we guessed correctly. And I don't know why I put a comma there. And there we go. Let's see if we guessed correctly and see if this actually is going to work. So what we'll do is we will grab two path spawners. Let's see, I think we said path connected X and path connected minus Z. So we'll grab this guy and drag him up to the top like so. And then we will delete this guy down here. So let's grab that guy, delete him. And then let's run this and see if we get what we're looking for. It should be a rotated 1. And that looks like it's possibly the incorrect location. Let me see. So it's from this direction and it should be going this way. Is it going that way? It is. So that is the correct direction. So now we need to just have it rotate 90 degrees, 180 degrees, and 90 degrees, much like we did with the other ones. So what we'll do is we'll go ahead and grab this, copy it, paste it, and then say path connected X and path connected Z, just like that. And we need to add in our rotation. So we'll go ahead and grab our rotation code from up here. Might as well not waste it. And in our case, that will do it. I think minus 90 will work. And then we need to do minus 180. So else if path connected minus X and path connected Z. Now, the reason why I'm pulling these out in such an easy way is because you have to remember your cardinal directions. So path connected minus X, right? So if X is over here, and Z would be down here. So now I know, like, okay, so path connected minus X minus Z, or path connected minus X, Z, so it'd be this way. It's just one of those things that I guess as you work with 3D space, it's a little easier to walk through. So we'll say 180, and then we will do the same thing for our next one, which will be path connected. You see, path connected X minus X, X, Z, minus X, Z, and then minus X minus Z. Because we don't have that use case yet. And what that will be is that will be 90, since we have no rotation, 90, 180. So that means that we have 90. Just like that. Now let's go ahead and test this real quick. So we'll go ahead and grab this spawner, drag him over here. So he should be facing this direction. So that would be this way. So we'll go ahead and run this. And that's correct. We'll grab this guy, drag him down here. He should be facing the camera going to the left. So we'll go ahead and check that out. That's correct. And then that means that we probably have the last one correct, but let's drag it over here anyway and see. So we'll run it. And that's what we expected. Perfect. All right. So last, we need to go ahead and just check to see if two values are correct at all, right? So if when we want to do our straight line, right, if path X and path minus X are both correct, that's fine. But if either one of them is correct, that's also fine, right? And same thing with Z. If one of them's correct, that's great. If one of them's connected, is good. If one of them is not connected, that's fine too. They don't both have to be connected. So what we'll do is we'll say else if, and we will say path connected Z or path connected minus Z, then we will just spawn our object like normal, right? So we'll just go ahead and spawn our object like this. Else if path connected X or path connected minus X, we will spawn it, but with a rotation of 90 degrees. So we'll just grab this guy and paste it, and we'll change this to path. I believe we named it path object, so we'll go ahead and do that. And we'll do the same thing here, path object, because we don't want to spawn a path turn object. So now, if we hit play, we should have straight lines. We already have a... All right, so now you will see that it works. Perfect. That's exactly what we wanted. So now that we have this, let's go ahead and do the final use case. And that is if we go to our test scene and we get rid of 2 of our spawners and we just have our original spawner, if we run this, we should get nothing. And we got nothing. And the reason why is because we are not checking if the case does not exist. So we need to have an else case. Else, let's just spawn a path object. Just like that. There we go. And that should solve that problem. There we go. So now we can spawn our objects. We can build our objects into a weird path or anything like that we want. So if we were to take this in our test scene and we were to duplicate this guy, drag it over, duplicate this guy, drag it over, duplicate him, drag him over here, duplicate, drag it over here, duplicate, drag it like this, this, and then create a 4-way object over here, let's say. So we'll just kind of drag him over like this. Let me move my camera a little bit so I get a bit better view. Duplicate them, drag them like that, duplicate them, drag them like that. That should work. It should make an actual path system like we expect. So we hit Control S and we play it. We should have everything working correctly. And there we go. Everything looks like it works correctly. Perfect. That's exactly what we wanted. So now, first, we can get rid of our print here because you can see we're getting output overflow. So we're printing way too much text. And what we can do now is we can set up our spawning system because we need to be able to spawn our objects by clicking on the screen, right? And we need to be able to move them around and delete them. So let's go ahead and start doing that. All right. So the first thing we're going to do is we're going to delete all of these path spawners. We don't need them anymore. We're going to right click our spatial node, add in a child node. And then we are going to go ahead and add in a CSG box here. And we're going to make it about, I don't know, about this big, give or take. We'll kind of pull this out, bring this down just a tiny bit. And we'll right click, add in a child node, add in a spatial static body node. We're going to right click that, add another child node, and we're going to go ahead and add in a collision shape node, and we'll make it a box shape, and we will scale it up to match the bounds. Now, I know that we should probably put the CSG box underneath our static body here, but it's really not that big of a deal, though if you guys want to do that, you guys can. Once we have this put in the way that we'd like it to be, which I now have it where I'd like it to be, I think, what we'll do is we'll go to our camera, we'll right click it, we'll go ahead and attach a script, and we'll call it camera.cs. We'll go ahead and click create. So now that we have our little camera.cs here, We'll go ahead and maximize this up so it's about the right size. And what we'll do is we'll go ahead and we'll get our click event started. So basically what we're going to have to do is we're going to have to raycast out of our camera and hit a plane and return back the location and the object that we clicked on. So what we'll do is we will go ahead and override a function that already exists inside of Godot. We'll come in here, we'll say public override void underscore input, and we will go ahead and say if at input event dot is pressed, and we need to check if it's a mouse button. So at event is input mouse button. And that'll basically check to see if we've clicked anything, if we've pressed a button, and if it's a mouse click of some kind. So I'm not going to specify a specific mouse click, but you guys can if you'd like. And then I'm also going to say else if at event not at event dot is pressed and at event is input mouse button, then we're going to do some code as well. So what this is going to do is we're going to say if we click on a thing, we're going to be able to select objects and things like that. And if we let off of our click, it's going to go ahead and allow us to stop, right? It's going to set our selected as done. Okay. So what we'll do is we're going to first come up here and we're going to go ahead and do a raycast. Okay. So much like we did before, we'll do physics, direct screen space state is equal to get world dot direct screen space. We're going to go ahead and say vector2 mouse position is equal to get our viewport dot get mouse position. And then we're going to go ahead and get our ray origin. So we'll say vector3 ray origin is equal to project ray origin. And we're going to pass in our mouse position. And what that's going to do is that's going to return back our ray origin location in 3D space where our mouse is in 2D space. And I'll go a little bit more in detail in this in a future video. I plan on basically creating a video explaining how to do physics raycast from your camera as like an actual tutorial. But in this case, just know that this works. And then we need to also determine our ray end. So we'll say vector3 ray end is equal to ray origin plus project ray normal mouse position multiplied by a distance that we want to shoot it, which is about 2,000 or so. 2,000 means we're going to shoot at 2,000 units. That's basically forever in Godot. And we're going to project a ray from our normal. So from where our camera is facing, it's going to shoot a ray out. And then what we're going to do is we are going to get our intersecting ray. So we'll go ahead and say Godot.collections.dictionary intersection is equal to space state dot intersect ray origin comma ray end. So what this will do is it projects out a ray and it comes back with a dictionary of parameters from the object it hit. So it'll come back with things like the collision body, the position, things like that. So now what we can do is we can check if we hit something that has collision. So we'll say if intersection dot contains collider, then we'll go ahead and spawn an object. Okay. So what we can do is I can kind of show you guys by hitting a little breakpoint here. hitting the run, playing it in editor. Let's allow Godot some time to boot up. And if we go ahead and click, you will see that we've done our intersection and our collision. We've actually done our raycast here. So if we go ahead and take a look at our intersection, you can see all the things that we get back here. So we get back things like our position, our normal, collider ID, shape, and RID. And basically from here, we can get back whatever we want, because we have access to a static body. The static body has everything, right? It's the entire object. So if I come into our values here, providing that it lets me, there we go. I can pull back our static body. You can take a look at it. And it has everything that you could ever need it to have, right? It's basically the object itself, right? And we could pull back methods from this object as well, which we will in the future. So now what we can do is we can go ahead and spawn our object. So we need to actually have a reference to an object to spawn. So let's scroll up to the top. We'll go ahead and say export, and we'll say public hacked scene path spawn obj. And then we'll come down here and we'll go ahead and say path spawner is equal to path spawner obj dot instance as a path spawner. That's going to go ahead and spawn our object as a path spawner. Then the actual path spawner is going to go ahead and do the logic to connect itself to any other path spawners that are around it. So now we need to actually make it a child of our Godot's root. So we'll say get tree dot get root dot add child, and we will go ahead and add the spawner as its child. And then what we can do is we can say vector 3, and then we need to move it to a proper location. So what we'll do is we'll go ahead and move it. We'll go ahead and we'll move it to the mouse location. So we'll say vector 3 position to move is equal to, and we'll need to cast this as a vector 3, right? Intersection position, and we're going to need to cast this as a vector 3 because it's not going to take it. So what we'll do is we'll come in front of here and say vector 3. That's going to cast it as a vector 3 for us. So now what we'll do is we'll go ahead and spawn our object in that location, and we'll go ahead and move it. So we'll say spawner dot translation is equal to position to move. And let's go ahead and test this. So we'll hit Control S. We'll stop this. We will come into Godot real quick, just like this. We're going to hit play. And let's see what happens. So if we click, we get a crash. So that's always a good sign. Null reference exception. That's because we forgot to put our path spawning object in our camera. That's my fault. I make that mistake almost every time I record. So now let's go ahead and hit play. Let's try that again. Let's hit click, and you'll see the object has spawned. If I click over here, you'll see the object has spawned and the object has spawned. So we definitely are achieving what we want. Now it looks like we're only getting back false, so that's not a good sign. But I am curious. So we've run into an age-old problem, and that's when physics gets really weird. So when you initially instance something in and that code is being ran, it's being ran under your frame time, not your physics time. So it's a totally different area of Godot, and we basically need to tell everything to run on the physics time instead of on the frame time. So how can we do that? Well, if we go ahead and open up Visual Studio Code here, and we open up our physics process here. So if we go to public override void physics process, this is Godot's physics processing. So instead, what we're going to do is we're basically going to tell the physics process to do it instead of having the frame time do it. So what I'll do is I'll come up here and I'll say public private bool updating is equal to false. And then what I'm going to do is I'm going to take out set path, and I'm going to say if updating, then go ahead and set path, just like that. And then I'm going to come down here to the bottom of my set path. Once it's done with all the things that we expected it to do, I'm going to come in here and say updating is equal to false. And that will basically handle our problem. And actually, I should probably set that to true so that it runs on startup, right? We want it to find the correct object on startup. So now from here, let's go ahead and go back to our project. Let's go ahead and hit play, and let's see what happens if we do this. So if we click and then we click, you'll see that this guy updated. If we click and we click, you'll see that this guy updated. If we click here, this guy updated to the correct one. So we're at least getting kind of the correct results. Some of these guys are now turning and raycasting properly, but you'll notice that when we instance in our object, it's not updating the objects around it. So that's a big problem, and we're going to need to fix that. So let's go back to our path spawner, and let's go ahead and do that. So what we'll do is we'll create a function called update objects around spawner. So we'll say private void update objects around spawner. And what we'll do is we'll go ahead and update all the objects around us. Now, the problem is we don't have access to those objects. When we raycast for our objects, we only get back whether or not they exist. We don't get back the actual object itself. But we also need that Boolean, right? So we have one of two options. We can either return back the object, or we can run through here and check for nulls like crazy. And it's up to you guys on which one you want to do. I'm going to go ahead and be a bit fancy on this. So it's up to you guys. But what I'm going to do is I'm going to come up to the top, create some references to our objects. And then I'm going to come down here and I'm going to use the out parameter for our functions. And that's going to go ahead and allow us to return multiple things. And it'll make it a little bit more flexible, if that makes sense. So let's go ahead and do that. So I'm going to scroll up to the top and I'm going to say private path spawner z raycast object. And then I'm going to copy and paste that 4 times. I'm going to say x raycast object minus z raycast object minus x raycast object. Okay. Then we're going to come down here, and instead of doing a path connected x, path connected z, minus z, and minus x, instead I'm going to pass that in here as an out parameter. So we'll go ahead and do that. So we'll pass these guys in like so. Just like that. And then I'm going to tell this instead to return our object. So we'll basically just pull, if I minimize these guys, which will make life a little easier on us. I'll just tell them to pull these objects. So we'll say, Z raycast object, that's this one. X raycast object, that's this one. Minus Z raycast object, that's this one. And minus X raycast object, that's that one. We'll get rid of our Booleans just like that. And we'll need to declare our Booleans. So I actually should have just declared them instead of doing what I just did, but that's okay. So I'm going to say bool path X connected, bool path connected Z, bool path connected minus Z, bool path connected minus X. That was my fault because I probably should have just copied it and pasted it up there. Now, if I come down here to my raycast, what I can do is I can come in here and I can say, comma, out, bool, object connected. And instead of returning true, I could say object connected is equal to true. And I could say object connected is equal to false. Okay. And then I can go ahead and I can return the object that we pulled. So what I'll do is I'll return result quote collider as path spawner. And then I'll do the same thing here, except for I'll just return null. And then we're going to need to change our return type. So we're going to return a path spawner. And that'll allow us to return a path spawner and a Boolean without needing to use a tuple. One of the big things that I don't like about tuples is that you have only like T0 and T1, right? That they're considered a list, right? An array of objects. And I don't like dealing with those. So instead, to me, it makes things a little bit easier if I can just go ahead and just return my Boolean as a out parameter instead. And what an out parameter means is that means when you put a Boolean in to this, it will come out as that value. You're basically creating a link between the Boolean you bring in and the Boolean you get out, if that makes sense. So now what we'll do is we'll come up here to our update objects around spawner, and we'll go ahead and say if raycast object does not equal null, then raycast object dot set path, because we know that it can set its path. And then we'll say if raycast object does not equal null, then let's go ahead and say raycast object dot set path, as you would expect. Then we'll also say if minus raycast object does not equal null, then let's go ahead and set its path. And finally, if minus raycast object does not equal null, then let's go ahead and set its path as well. There we go. So now that we have this, what we can do is we can say, hey, in our set path, once we're done with setting our path, we can just update our objects, right? So we'll just say update objects around spawner, and that's going to go ahead and update the objects around us. So then what we'll do is we'll come over here to our physics process, and we'll go ahead and say update object around spawner, and that will basically go and update all the objects around us. Now, if we go inside of Godot and we hit play, and we click, and then we click, you will see that it's kind of doing what we want, but it's not quite doing what we want. It's sort of right, but just for some reason, it's just not quite there. So let's see what's going on. Let's go ahead and see if maybe it's our updating. Perhaps we need to put that later. So let's go ahead and get rid of that. And let's scroll up and see if maybe we need to do it after our update instead. So what we'll do is we'll go ahead and create a small helper function. So we'll go ahead and say public async void initial set path. And that's probably not a great name for it, but I'm not exactly great at naming things. So we'll just go from there. What we'll do is we'll wait for a quick second to just kind of let everything settle, because we just instanced everything in here. So there might be some things that need to be cleaned up. So we'll go ahead and await to signal. We'll go ahead and get our tree, and we're going to wait for our physics frame. And then what we'll do is we'll set our path, and then we'll update all of our objects around our spawner. And then we'll go ahead and set updating equal to false. And then we'll come down here and we'll just kind of get rid of our updating is equal to false. And let's try that and see if that works instead. So we'll change this to initial set path. And basically what this is going to do is it's going to kind of dump this out into its own little thread for a second. So it can kind of think about what it needs to do all of its raycasts and handle it from there, instead of waiting for Godot to just kill it off or to try to keep our game going. Instead, it's just going to be off in its own little space where it can do its thing. So let's go ahead and see if that works. And if that works, then we'll be good to go. So let's go ahead and click, and then click, and it does work. Nice. Great. So that's what we wanted. So there we go. Yeah, that works. I mean, I'm not exactly great at clicking, but it does work. So that's great. Awesome. So now that we have that, let's go ahead and fix our slight problem with things being put in the wrong position. So if we go over to our camera, let's change this from 1 to 2, and that should probably fix that. So let's see if that fixes it. And then what we'll do is we'll go ahead and set up our deletion system. So let's click. There we go. That's much more efficient. That's way easier to work with. Cool. So now what we'll do is we'll go ahead and set up our deletion system. Now this should be pretty quick and pretty easy. So what we'll do is we're going to go ahead and check our collider and see if it's a path spawning object. If it is a path spawning object, then we can go ahead and say, hey, this object already exists. Let's select it and say it exists. And then we can create a small button that just says, hey, when we click this button, it's going to delete the object. Okay. So what we'll do is we'll come up to the top and we'll say private path spawner selected node, like that. And then what we can do is we can say if intersection dot contains collider, then if intersection collider is a path object, so it's a path spawner object, then what we can do is we can go ahead and set our selected, right? So we'll say selected node is equal to intersection quote collider as a path spawner, just like that. And then we can say else it must not be a path spawning object. So we can go ahead and just spawn it and make it exist. It's something that we can spawn on, so we're good to go. And then what we can do is we can go back to Godot, right click on our spatial node, add a child node, add in a button, and then let's go ahead and make it about yay big. Let's call it delete object. And we'll go ahead and copy the name, go to our button, paste it, delete object. There we go. I'll probably make it just a touch bit smaller. There we go. And then what we can do is we can hook up our signals. So we'll go to our node, go to our signals, double click on button down, copy this, make sure you copy this, connect it to our camera, and then come down to the bottom and go public void on delete button down. Let's go ahead and delete our object. Now, we should not attempt to delete our object if it doesn't exist. So if selected node does not equal null, then we can go ahead and attempt to delete our object, right? So normally you would just say queue free, right? Just go, get rid of it, be done with it. But when you delete your objects, you're going to want to tell everyone around you, hey, I need you to update your path type, right? Because if you delete a four-way, right, you don't want everyone to still think there's a four-way there. Or if you have a straight line next to a elbow, right, you want that elbow to go back to a straight line if that other straight line gets removed, right? So what we'll do is we'll go to our path spawner, we'll scroll down to the bottom, and we'll say public void remove object, just like that. And we'll make that actually void. And then we'll go ahead and put some logic in here. So if we go back to our camera and we say selected node.delete remove object, just like that, that will allow us to remove our object. If we go back to our path spawner, let's go ahead and code this little removal section. So what we'll do is we will go ahead and update. And then what we'll do is we'll also set another Boolean called removing. Now remember, like I said before, with physics, it gets funky. We don't want to block our thread of our render thread at all. We want to only block the physics thread. So we need to tell it to do everything in our physics process. So what I'll do is I'll say removing is equal to true, and I'll come up to the top and I'll make a function, a Boolean that says removing. So we'll come up here and we'll say private bool removing, And then what we can do is we can come down here to our physics process and we can say if removing, then let's go ahead and delete ourselves and tell everyone around us to update. Okay. But we can't just tell everyone to update around us because we still have collision. So when they raycast towards us, we're going to say, hey, we're still here, right? Because we haven't been deleted yet. We have to wait until the end of our physics frame to get deleted. So what we have to do is we have to set our collision shape to nothing, or at least to disabled. So let's go ahead and do that. So we'll say get node as a collision shape dot disabled is equal to true. And then we need to go ahead and update our objects around our spawner, right? So we can update our objects. And then we need to delete our object, right? But we can't just queue free, because if we queue free, it will delete it before our updates are all done. I know this is weird and kind of funky, but that's just how it works. It's really weird and I don't like it. But what we'll do is we'll come into our initial set path. We'll go ahead and say if removing, then let's go ahead and set another Boolean called ready to remove equal to true. And I'm going to go ahead and come up here and create that. So private bool ready to remove. And then we'll come down here and we'll say if ready to remove, then let's go ahead and queue free. Just like that. And that should about do it. So I'm going to go over here. I'm going to click on the play button and I'm going to go ahead and test this. So let's go ahead and run this. Click, click. You'll see it switches. It switches. It switches. If we click this object and we delete it, you'll see that this guy becomes a straight line. This guy resets to his original position. So there we go. That's pretty much all we need to do to get our deletion system to work. Perfect. That's exactly what we wanted. So now from here, let's go ahead and set up our movement system. So what I'll do is I'm going to go ahead and go into my path spawning code here, and I'm going to go ahead and set up a moving function, because every time we move it, we need to go ahead and update our objects around us and ourselves, right? So what we can do is we can come down here and we can go ahead and say public void move object. We'll go ahead and pass in a vector 3 and we'll pass in a position. There we go. And we'll go ahead and say updating is equal to true. And then we'll go ahead and say translation is equal to position. And that's pretty much all we need to do on this end. So now let's go ahead and go over to our camera and let's set all of this up. This is where all the difficulty is probably going to come in. So what we need to do is we need to go ahead and set if our object is moving, and we need to go ahead and basically say on click down, we're moving, and on click up, we're not moving. Okay. So what we'll do is first, we'll set up our movement system. So we'll go ahead and scroll up here. We're going to set up a Boolean here. So we'll say private bool moving. And we will go ahead and come into our process node here. We'll hit Control-Shift-P, toggle line comment, and then let's go ahead and say if selected node does not equal null and we are moving, then let's go ahead and move our object. So we'll say, so we need to actually raycast for our object. Now we have all of our raycast code right here, right? But we don't want to sit here and waste our time writing the same code over. So let's go ahead and abstract this out to a function. So we'll go ahead and cut this just like so. We'll come down here and we will go ahead and say private Godot dot collections dot dictionary raycast for object. And then we'll go ahead and paste that code just like that. Now we have our Godot collections intersection is equal to a screen space intersect ray. So we'll go ahead and hit Control X, and we'll go ahead and say return our raycast here. And then what we'll do is we'll scroll up to the top, and you'll see that this says, hey, you don't have an intersection. So let's just go ahead and paste this, and is equal to raycast for object. And there we go. So we basically just put all the code down here into a little function. So now if we scroll up to the top, we'll go ahead and raycast for an object here. So we'll say vector3 position to move is equal to, if we cast this as a vector3, raycast for object, and then we go ahead and say quote position, just like that. And then we can go ahead and say selected node dot move object and pass in our position to move. Now you'll notice that this will work, but we are not snapping our object like we normally would. So we're going to need to do that. So what we can do is we can just say snap to position to move, comma 2, and there we go. And that'll go ahead and snap our object. Now, after this, we need to select our object so that way we can move it. So what we should probably do is we should probably come down here to our selection section here, where we're doing our selection. And we'll go ahead and say moving is equal to true, because we want to be able to move it while we click on the object. And then when we let off of it, we want moving to be equal to false, right? So we'll say if selected node does not equal null, then let's go ahead and set moving equal to false. There we go. So now if we go ahead and test this, let's see if this at all works the way we want it to. So I'm going to go ahead and hit play. We'll go ahead and click, and then we'll click, and you'll see it moves like we would expect. So if we click a couple of these guys in, we pull this guy away and bring him back, you'll see he updates the way you expect it. If you pull it away, it works as you would expect. Now you did notice that we have a crash here. System collections, generic key was not given in dictionary. The reason why it crashed was because out in our camera here, we are not checking if the raycast for object is null. So we need to do that. So what we can do is we can just say Godot collections dictionary is equal to raycast for object. And then we basically can just copy this code right here and then paste the code right there and put it like that. And basically that guarantees that we're at least not going to be completely broken while we do this. So now if we go back here and we spawn in a couple of objects just like this, if we drag this guy over here, you see he snaps. And that's basically what we want. Now you'll notice that this guy did not update when we pulled him away. See how this guy didn't update either. So that is a slight problem that we're going to have to figure out why it's doing that. But you can see that it does actually work. And if we delete it, it works like you would expect. So basically my guess is that we need to tell it when it moves to update everybody as well around it, much like what we did before. So if we go back to our CS project here, let's go ahead and see. Actually, I think I know what's going on, because when we delete an object, we get rid of our collision, don't we? Yeah, we remove our collision shape. So we need to disable and enable our collision shape when we're moving. So that's something that we're going to have to do. So what we'll do is on camera, we're going to need to disable our collision shape and re-enable it. So what we'll do is we'll come in here and we'll say selected node dot get node collision shape dot disabled is equal to true. And then we'll basically do the same thing down here, but basically just say false. And let's go ahead and test this. So we will come over here. We're going to refresh our screen. we'll click, 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 drag this guy away, and I have a crash, so that's never a good sign. Node not found, collision snape. I spelled shape wrong. I used an N. There we go. Let's try that again. And actually, I did it a second time. I spelled it wrong 2 times. So we'll go ahead and hit play. Let's go ahead and click, 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 click. Let's drag this away, drag this in, and you'll see that it updates it just like you would expect. Nice. And if we click it and delete it, now if you look at our debugger, you see that we have a cannot access a disposed object. Now the reason why that this exists is because what we're doing is we're queue freeing our object over here. We're actually removing our object down here. And we have our object selected up here still. So you need to be careful of that because a lot of times if you have references to that object, you need to go ahead and stop and delete all references to that object before you go ahead and delete an object. So if we come down here to our button down, if selected node does not equal null, let's go ahead and say selected node is equal to null. And that'll go ahead and prep everything to be deleted and to be settled. So now if we hit play, let's try that one last time and we should be good to go. So if we click, 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 click this object, delete it, there we go. Simple enough. So now everything works the way that we expect it to work. Perfect. So that is all I have for you guys today. So we went through the process of building an entire path system. And doing so, it taught us about raycasting from your screen to another object. So from 2D space to 3D space. We talked about how to detect objects around us and change out our object based off of those objects. We also talked about how to move an object on a grid and how to do snapping. And we also talked about how to safely delete objects that are on a physics thread because that actually matters. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video, as with all of my videos, was a viewer suggested video. So if you have any suggestions, please leave them in the comments below and I'll be more than happy to get to them at some point in time. My list is very long, so it does take a long time, but I will eventually get to them. I do have a WebRTC tutorial in the works and a Blender tutorial as per usual. But if you guys have any suggestions, please leave them in the comments below. And hey, if you guys have any questions about this or any Godot questions really in general, please throw them in the comments below or hit me up on my Discord. Link is in the description and I'll be more than happy to help you guys out. But that is all I have for you guys today. So thank you so much again for watching and I will see you all next time. Thanks.